Hi there, my name is Peter Marinelli and I'm doing my senior project on the Interchangeable Backpack designed for Manufacturability. And my technical advisor for this project is Dan Waldorf. So what I'll be talking about today is I'll be going over the background of backpacking and backpacks and how this relates to my new backpack design project, as well as the problem statement, the objectives that I hope to cover in my senior project, literature review to cover all the information that I had to research going into this project, and looking ahead what I'm planning on doing next quarter to complete this project. So a little bit of background. Starting off, what is backpacking? Backpacking is a combination of hiking and camping, where you're hiking in with all the necessities to go camping. So typically this is with a mid to large backpack, so you can carry everything on your back, hike in however far you want to go, anywhere from 1 mile to 100 miles in, set up camp, and keep on going day after day after day. A brief history on backpacking. The original backpack was created, the original backpack was created in 1920, and it was designed so that an explorer could be more comfortable and hike longer distances with a more solid frame, where all the previous frames beforehand were very loose and they ended up hurting the back and the hips a lot more than the new design did. So once this new design came into effect, it kept on progressing, and next they came out with the external frame pack, which has an external aluminum frame to attach the backpack and strap it over your back. And then the internal frame, which is internal inside the backpack itself, which typically is close to your body and a little more comfortable and has more, supports the backpack more with your hips. So for my backpack design, I came up with it when I was on a backpacking trip this past summer. I was hiking for about a week, and I had my large backpack. But a number of times I wanted to go off the trail and do a little summit, climb to a mountain, or do a small little day hike away from camp. And I didn't really want to bring my entire backpack because that's just really big and bulky. But then you face the problem if you want to bring a different bag so you can do those. Those are also bulky. You don't want to carry those in your backpack the entire time. So I came up with the idea, there's the problem statement, design and manufacture an interchangeable backpack to back panel interface that can meet your multiple needs on a long expedition hike and still be lightweight and compact. So my idea is to be able to detach the back panel from the backpack bag and have multiple backpack bags at the same time. They can compress down to a small size and still be very lightweight and very compact, so you can put it inside your expedition backpack and take it with you without taking up a lot of weight or space. So my objectives for this project, my goal is to identify a type of interface temporarily but securely adjoin the back panel to the backpack bag. We'll be talking about that in a little bit, as well as reducing the volume and weight of the backpack bag and storage by 50%. So because there is only one back panel, you'll be wearing that one back panel, and the actual backpack bag should be a lot lighter and a lot smaller, so you can fit it easily in your big backpack. Then I'll be designing a backpack based on these previous criteria and designing for manufacturability, which we learned in IME 241. Next I'll be creating a bill of materials that's required to create this backpack on industrial commercial scale. And then the next couple weeks I plan on building a prototype backpack bag slash back panel system that accomplished the previous objectives. And this will be pulling from my knowledge of IME 142 with metal bending and welding, as well as IME 144 and IME 341, which is fixture design. My next objective is to design a manufacturing process to further manufacture this as a commercial product. This will be taking knowledge from IME 418 as well as 341. And then my last objective is to determine a production cost required to manufacture this product on a commercial scale. commercial scale being about 50,000 products per year. And this will be pulling knowledge that I learned from IME 241 as well as 341. For my literature review, one of the things that I looked up that I researched was different types of temporary joining interfaces. So there's a list there of different ways to connect two fabrics securely but not permanently, so that you can detach it when you want to, but it'll stay together when you want to as well. So some of the ones that I researched were buttons, Velcro, buckles, zippers, and snap fasteners. The next major thing that I researched was different backpack materials. So there's a whole variety of different materials. Some of the old backpacks use different types of cotton canvas materials, where the new backpacks are using different types of nylon and nylon ripstop, as well as some more advanced materials called Cordura, Dyneema, polyester pack cloth, and Spectra, as well as a number of other ones that'll be in the report. Then for backpack and frame design, I already kind of went over external frame backpacks. Those are the ones with the large aluminum tubing that you can see on the outside of the backpack that attaches to the actual bag behind it. Those ones are good for big, bulky things to carry, and you can attach a lot of things onto the outside of them. Where aluminum frames, which are newer, they can't always fit as much stuff, but it's close to your back. It's close to your body center of mass, which makes it easier for you to carry. And you also have a hip belt on that works better than the external frame ones, that takes the weight off your shoulders and distributes it across your lower back and your hips. Another thing that I researched with this was weight distribution and how to properly distribute the weight in your backpack, and how to design for that, how to design my backpack for that. Then I also compared other different types of backpacks that are fairly similar to mine. The MOLLE backpack, which stands for Modular Lightweight Load Carrying Equipment. This is a modular military backpack that they use, where you have different bags that you can attach one after another, or take them off to a back panel, so that you can carry large expedition packs that weigh 60, 70, 80 pounds, and you can add or take off the different attachments to be any size that you really need. And then there's also a company that's called Boreal, and they have a series of backpacks called the Bootlegger. This is a fairly similar idea to mine, where you can detach the actual bag from the back panel, but theirs is on a smaller scale. They can only do it for a hydration day pack, a regular day pack, as well as a dry bag. They're all small. And then the last one that I was looking at was called the Wild Thing Andonista, and this is a backpack that can be a full-size backpack, and then it has zippers on the side that you can zip up, and that compresses it down to just a regular day-size pack. But it only has two sizes, big and small, and there's nothing in between. So looking ahead, what I still have to do for my senior project, I need to finalize my product design, which I'll be getting done in the next couple weeks, as well as building a prototype for it, which will also be getting done fairly soon, hopefully over break. And then once I have a design and a prototype, I will design a manufacturing process, and this will include the equipment that I need for it, as well as the fixtures and jigs required, as well as the sequencing, to design and make my backpacks for about 50,000 backpacks per year production rate. Then the last step is to create a cost analysis breakdown, and this is to analyze how much it would actually cost to build my backpacks on an industrial commercial scale, and if it's actually a viable option for being able to sell it on the market. That is my presentation. I hope you like my project. My project is the Interchangeable Backpack designed for manufacturability, and my name is Peter Marinelli. Thank you so much for your time.